Hi guys. So the body will always look for a way to balance things up, all right? Especially in the internal environment. All right. So that idea of balancing things up within the normal range in the body is called homeostasis. So in this video, we're going to be taking a look at homeostasis. All right, so homeostasis is simply the regulation of a fairly constant internal environment. As simple as that. All right, so like the name implies, homeostasis. Homeo actually stands for similar. So let's write that down. Homeo, similar, and stasis, balance. All right, so homeostasis is simply similar, balance. All right, now the whole process of homeostasis has about 6 components, and we're going to mention that because that is what we are going to be walking through when we want to talk about this whole pathway here. All right, so the first component, or one of the components that I'm going to talk about first of homeostasis, is called stimulus. All right, so number one, stimulus. And for homeostasis to occur, there must be a stimulus. So what is a stimulus? A stimulus is just a reaction, a change in environment. Okay, now this stimulus can be internal stimulus or external stimulus. All right, so this can be a change in environment, and the second that follows is what we call the receptors. There must be a receptor. Second component, receptor. All right, so what is a receptor? A receptor is just something that binds to molecule, something that is able to fix a molecule or binds to a molecule. All right, now the receptor aids or helps in transduction. It helps to transduce the stimulus into what you call an action potential or into a signal, especially when it has to do with an external stimulus. All right, now number 3 is what we call the afferent signal. Now, what is this signal? This signal is actually the signal sent from the receptor to the control center. All right, so that brings us to our next component here, which is the control center. The control center. And most times, this control center could be the pancreas, like in this case, it could also be the brain, and more precisely, the hypothalamus of the brain. The hypothalamus of the brain. All right. Now, the next is the efferent signal. The efferent signal. The efferent signal. Now, this is a signal sent from the control center to the effectors, which brings us to the last, called the effectors. And effectors could be cells, could be glands, and even muscles. All right, so these are the basic components of homeostasis. Now, coming over here, we're going to, looking at this structure, you should already know what this is talking about. Okay, you have the pancreas, you have the liver, and you have the blood vessels, and you have the cell. So this is clearly talking about a hike or a drop down in glucose. Okay, so let's assume we have in the blood vessel, we have a hike in glucose. Now, that glucose itself, the glucose itself is called the stimulus. All right, so that is an internal stimulus. So the glucose is the stimulus. So when you have a hike in glucose, when you have a hike in glucose, what happens is that the body immediately senses that there's a hike in glucose. Now, the pancreas is very important. It has receptors on it. Now, what does the receptor do? The glucose molecule bind to the receptors of the pancreas. So this glucose molecule, they bind to the receptor of the pancreas. Now, when this happens, the pancreas senses that, oh, there is a, a hike in glucose. Okay, since the pancreas is a control unit, okay, let's say the stimulus is the glucose, right? The receptors are the receptors on the pancreas. The afferent signal is actually the signal that is sent from the receptor to the control center, which is the pancreas itself. So this pancreas receives this signal, this stimulus, and takes it into the pancreas. And the pancreas will always look for a way to balance up something. Now, what will happen here? When it receives this signal, the pancreas will release a hormone called insulin. A hormone called insulin. So the pancreas will release insulin. The pancreas will release this hormone called insulin. What does the insulin do now? The insulin travels to the blood vessels and cause some channels of the blood vessels to open up, and the glucose molecules will leak into the cells. All right. So the efferent signal now is the signal that is sent from the control center to the effectors. The efferent signal sent from the control center to the effectors. I said the effectors could be cells, which are these cells, glands, or muscles. All right. So these are cells. All right. So when the insulin gets into the blood, it helps to move the glucose molecules in the blood into the cells, the tissue cells. All right. So this glucose molecule gets in, they are now trapped in the cells here. They are now trapped in the cell. Now, when this happens, something dramatic happens. Immediately, the blood glucose will return back to normal. All right. It will drastically lower the glucose level in the blood. Now, that response is what we call a negative feedback. All right. So let's just put that down here. Um, that is what we call a negative feedback. A negative feedback. All right. So the stimulus from the stimulus gets to the receptors. It is taken to the control center, which releases a hormone that goes to balance things up. All right. So if negative feedback counteracts the effect of a stimulus, so when something happens, a negative feedback counters. So a negative feedback is a feedback that actually stands at the opposite side to say, oh no, this should not happen. So I would help to return the body back to normal. So when all this process happens, that is what we call the negative feedback. All right. So it counteracts. It counteracts. Sorry, the body is becoming messy. It's very small. It counteracts the effects of the stimulus. All right. So what if we now have a decrease or a decline in blood glucose? Same thing happens. The pancreas senses a decrease in blood glucose, and mind you, these receptors are called GLUT receptors. GLUT receptors. All right. Now, this glucose binds to the receptors also. Okay, so when this binds here and it senses a decrease in blood glucose level, the pancreas would want to look for a way to foster the production of glucose. Now, what does it do now? It releases another hormone. Now, a hormone it releases this time is not insulin, but what we call glucagon. So it releases glucagon. All right. Now, these glucagon are trapped by the receptors of the liver. All right. So when they are trapped by the receptors of the liver, what does it do? It tells the liver, oh, we have a decrease in blood glucose. So what you should do is make more glucose. So the glucagon helps the liver to synthesize more glucose. So more glucose are synthesized, more glucose molecules are synthesized in the liver and moved back into the blood stream. All right. So this is just what happens in homeostasis. The same thing happens when we have things like in temperature. Okay. So you have the sun hitting you so much that your temperature increases. Remember, the sun is an external stimuli. It hits you so much that your temperature increases. When your temperature increases, what happens is that that stimulus is the temperature. The receptors are the thermoreceptors on the skin. So the receptors receives that signal and sends the afferent signal, receives the stimulus and sends the afferent signal to the control center. In this case, it is the brain. So the brain now tells the now releases the efferent signal to the effectors, which in this case could be sweat glands, and you start sweating. And when you start sweating, that is a negative feedback. Okay, that's a negative feedback. All right, so let's quickly talk about positive feedback. So what happens in positive feedback? What happens in positive feedback? Let me take this off. Okay, I don't even know. Um, let's take this off. So in positive feedback, we do not really have much examples for positive feedback, but the very common one is labor. When someone is in labor and a woman is trying to deliver. All right. So what happens is that the baby will be pushing against the cervix. All right. So you have the contraction of the uterine wall. You have the contraction of the uterine wall, and the baby will be pushing to the cervix. All right. Now, as the baby is pushing against the cervix, what happens is that instead of the body to look for a way to stop the baby from pushing against the cervix, it amplifies the push. Okay, so it amplifies that push. What happens is that the stimulus, which is that pressure, that push, is received by the receptors in the uterine wall, which is sent to the control unit, which is the brain, telling it to release a hormone called oxytocin that helps to further contract. Okay, so the oxytocin helps to further contract the uterine wall, pushing the baby more harder against the cervix until the baby is born. When once that baby is born, the process stops. Okay, so positive feedback does not counteract. Instead, it amplifies. All right, so take that home. Positive feedback amplifies, negative feedback counteracts. All right, so this is an example of a positive feedback. All right, so this is just an overview of homeostasis. So thank you and see you in my next video.